Okay, this is going to be about a five-part mini-series over the binomial theorem, and this is part one. And I'm going to begin this part one with some little bit of review from the factorials back in 9.1, because I need the factorials to discuss a topic called the binomial coefficient, which is our next thing on part one. And so on the factorials, if you have n factorial, what that is, it's a product of the starting at 1 times 2 times 3 all the way up to that number itself, n, where n is some positive integer. So it doesn't work for fractions, decimals, or things like that. It doesn't work for negative numbers. So, and by definition, we write 0 factorial as 1. Now, an example I like to give always is 5 factorial. Now, 5 factorial is the product of 1 times 2 times 3 times 4 times 5. And if you do that on a calculator, that would be 120. As a matter of fact, this button is on your calculator. TIs have it in some place, Casios have it in other places. And so if you can't find that button on your calculator, it is a lifesaver sometimes when you're in a time crunch. Instead of having to try to multiply these numbers out manually, with that button, it can save you a lot of time. And most people can find it, but if you can't, just either see me or look at your manual, and you can find it that way as well. So, but this was back in 9.1. This was previous to 9.5, of course. And but anyway, the next thing we're going to talk about is something called the binomial coefficient. Now, some of you guys may have heard of this, but using another term. And that other term is called a combination. And in Math 135, we call it the binomial coefficient, even though it's really a combination. And in Math 130 people, when they take that class, they would call it a combination. They would not call it the binomial coefficient. But what it is, it's basically having n items, and you're going to choose r of them. You're trying to figure out how many different possibilities, how many different choices or combinations can you make with that. And the formula is n factorial divided by r factorial over n minus r factorial. And again, this button is on your calculator as well. You can look in your manual, you can see me, and I'll show you where that button is located. This one's definitely a lifesaver if you can actually figure this out on a calculator. But here's an example that I like to choose. It's 5 choose 3. And so it's 5 factorial over 3 factorial, and then 5 minus 3 factorial. And when you do the math, 5 factorial over 3 factorial, 2 factorial, because 5 minus 3, of course, is 2. And 5 factorial, which remember we'll go from it, is 120. So 120. 3 factorial is 1 times 2 times 3, which is 6. 2 factorial is 1 times 2, and 6 times 2 is 12. And 120 divided by 12, of course, is 10. Now, 10 in itself may not make much sense to you, but that's what they're basically saying is if you have 5 items and you're going to choose 3 of them, there are 10 choices you can make, 10 combinations you can make with that. So let me give you an example of what I'm talking about. Say you have 5 choices in, let's say, textbooks, okay? And you're going to choose 3 of them, and you're going to send 2 of them back to the teacher or whoever. You don't want 2 of them, you're going to choose 3 of the 5. So if the books, let's label the books A, B, C, D, and E. So you could take books A, B, and C, if you like, and send back D and E. Keep the A, B, and the C. Or you could pick book A, B, and D and send back C and E to the publisher or to the teacher, whoever. And then you could pick books A, B, and E and then send back C and D, of course. Or you could pick A, C, and D. Okay. You could also pick A, C, and E. All right. You could pick books A, D, and E. So we're up to 6 already. Okay. And I think I've exhausted all the possibilities that have A in it. So we could also pick books B, C, and D and send back A and E. And I could pick books B, C, and E, and B, D, and E. And there's only one other choice, C, D, and E. And so if you pick books C, D, and E, you'd be sending back A and B. So now, a lot of people see this and they say, well, can't you rearrange the letters? Well, you know, if you think about the CAB part, for example, CAB, is that a choice? Well, it is a choice, but you've already had that choice when you picked the ABC. The order that you pick the books really doesn't matter. You can pick the books ABC, books B, you know, BCA. It's the same three books, either way you look at it. So it's really just one choice. So anyway, so this is not really another choice. It's just, it's already been there. So how many choices are there? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So that's what that is basically saying, is if you have n items and you're going to choose R of them. Now some of them are not, some may get sent back and some may not, depending on how many you want to choose. And so if you have 5 and you choose 3 of them, there's always going to be 2 sent back. So anyway, there's going to be 10 possibilities. So on the same token, if you have 6 and you're going to choose all 6 of them, well, obviously there's only one way that's going to happen. You're going to pick all 6 of them, none of them will get sent back, and there's only one way that's going to happen. So 6 choose 6, of course, is 1. So and if you use the formula, okay, 6 choose 6, well, 6 factorial goes on top, r factorial, which is the bottom number, 6 factorial, and then 6 minus 6, which is 0 factorial. And of course, the 6 factorials cancel, and you get 1 over 0 factorial. But remember, 0 factorial was defined to be 1, and so that will be 1, because it's going to be 1 divided by 1, which would make sense anyway. I mean, you think about it, 6 items, you're going to choose all 6 of them. There is only one way that's going to happen. Now, that's the easy one. If you had, though, 4 and you choose none of them, a lot of people think, well, there's not, if you're not going to choose any of them, that makes sense, that should be 0. Well, not really. Think of it this way. You have 4 textbooks, and you're not going to choose any of them. There's only one way that's going to happen. You're going to walk out empty-handed. So that's one way that's going to happen. Nothing. You get nothing. So 4 choose 0 is one way. You send all 4 of them back. So that's the one thing that happens. You send all 4 of them back. You keep nothing. One way. Now, and it's going to that explanation makes sense, because when you use the formula, 4 factorial over 0 factorial, because that's r, and then 4 take away 0 will be 4 factorial. And of course that cancels, and then 1 over 0 factorial will be 1 again. So that one is going to be 1 as well. So, but I'm trying to show you that the binomial coefficient is the same as a combination, which is what a Math 130 student would understand. And you guys are just going to be using it in a different way, using the binomial theorem, which is the topic at hand in 9.5. So the next part, I'm going to talk to you guys about something called Pascal's triangle, and how Pascal's triangle is related to the binomial coefficient. So that will be our second part.